Hi, in this video, we're going to look at some more free fall problems. So let's ask this question. How long would it take a penny dropped from the Empire State Building to hit the ground if there was no air resistance? So the Empire State Building is 443 meters to the very tip top. So that's our distance traveled here. We're going to list our other given information. We know the acceleration of the penny is going to be negative 9.81 meters per second squared. Another key piece of info here is that the penny is dropped from the Empire State Building, and when you drop something, it starts out at rest. And so the initial speed is 0. We said before the change in the position of the penny is it's moving down 443 meters. Important to include that downward motion here. So how long does it take the penny to fall? How long until it hits the ground? So we need an equation that has all of these pieces so that we can put in together to solve this puzzle. All the pieces are found in this equation here. We have delta y is VIT plus 1/2 AT squared. All right. Substituting in our numbers here, we know that displacement is negative 443 meters. And that's equal to the initial speed of 0. Okay, so 0 times the time here is going to get rid of that whole term, plus 1/2 times negative 9.81 t squared. Okay, so we get rid of this term here in the middle. We're left with 443 times, went ahead and multiplied the 1/2 times the 9.81. So it's negative 4.91 meters per second squared. We need to get this isolated, so we need to undo the multiplication here. And so we divide both sides by 4.91 meters per second squared, making sure we keep that negative sign with it, because now when we divide, we end up with a positive 90.2 seconds squared. And that's equal to the time squared. So to solve for time, finally, we undo the square root. We undo the square by doing the square root on both sides. And that gives us a time of 9.50 seconds. And time is always positive, so you should get a positive answer there. If you find that you get to this step right here and you need to take the square root, but you're trying to take the square root of a negative number, what that usually means is you forgot to include the negative sign on the displacement. It's easy to think, okay, 443 meters is my distance, but it's easy not to forget that that needs to be a negative value because it's moving in the downward direction. And if you don't put a negative sign there and you divide by this negative value here, you end up with a negative here and it messes up your problem. All right, let's look at one more example. Oops. All right. Let's say a golf ball is thrown upward in frustration at a speed of 32.2 meters per second. That's a blistering speed. So 2 questions. Let's start with this one. Question 1, how high does the golf ball go above the point of release? So here's a sketch of the golf ball being thrown up. So we know that the acceleration of the golf ball is going to be negative 9.81 meters per second squared. The initial velocity of the golf ball is 32.2 meters per second. Now, important in the question here is it says, how high does it go? All right, well, how high it goes is how far it goes before it stops and turns back around, right? The height is going to be all the way at that peak of that trajectory. And we know something about the peak here, something that we have learned about the peak of a ball's trajectory is that the speed is 0 just for an instant before it comes back down. And so we need to use that information of the speed being 0 at that final peak. And we're going to say that that is our final velocity for this problem. Now, in reality, the ball keeps going and ends up hitting the ground, right? But we're just going to narrow our focus to just the moment when it reaches that peak, and that's going to be called our final velocity. So we can choose where our final and initial values are. Initial is here, final is at the peak. So the final velocity at the peak is 0. So how far does the ball go up into the air? How high does it go? That's delta y. Now, we don't have a time measurement here, so the equation that we're going to use is this one, vf squared equals vi squared plus 2a delta y. All right, substituting in, we have a lot of numbers here, so just try to follow. We got 32.2 meters per second, but that gets squared later, and then plus 2 times 9.81, and then we have delta y. 0 is over here for vf. Squaring 32.2 gives us 1,040, and then we have 2 times 9.81 gives us 19.6. We're going to move this 1,040 over to the other side of the equation, so we're going to subtract it on both sides. So that leaves us with down here, negative 1,040 equals negative 19.6 meters per second squared. We're going to need to undo the multiplication here to solve for delta y, so we're going to divide both sides by negative 19.6. And then the meters squared over second squared and the meters per second squared, they all cancel out except for that extra meter up top, so we're left with units of meters. The negative signs cancel out and give us a positive answer because the ball is moving up. That makes sense. The answer here is 53.1 meters into the air. On the other question, it says, how much time does it take for that ball to reach the peak of its trajectory? So we're dealing with the same situation here. It's reaching the peak of its trajectory again, but how much time goes by? So all the given information is the same over here. The only difference is we're now asked to find the time. So knowing all of the pieces, the best equation now becomes this original equation for acceleration, the change in velocity divided by the time. Now, if you remember from a previous video, we can algebraically swap the time and the acceleration here to solve for time. We do that by multiplying both sides by time and then dividing both sides by acceleration. So a quick swap of those gives us this equation. So we substitute into that equation, the final velocity was 0 minus the initial velocity of 32.2 meters per second. Divide that by the negative 9.81 meters per second squared. That gives us negative 32.2 divided by negative 9.81. It's important to keep those negative signs consistent because those end up canceling each other out and gives us a positive value for time, which we would expect, of 3.28 seconds. So that's all I've got for you in this video. Remember, everything you have is a gift.